I'm here at our BGS SuDS observatory, where we're investigating how these sustainable drainage systems impact on groundwater recharge. Now, although a lot of these car parks look the same, there's subtle differences between certain areas of them. Some areas are permeable and some areas are impermeable. And what we're trying to do is investigate how these permeable areas impact on groundwater. To investigate how these SuDS schemes are affecting groundwater, what we've set up at the observatory is we've been monitoring for about a year groundwater levels in a number of different boreholes around the observatory. We've been monitoring groundwater quality, so looking at if there's any impact on groundwater quality. And today we've been installing some soil moisture sensors, so to look at the flux of water through the unsaturated zone and see how quickly water is being recharged to the water table.
I'm Andrew Butcher, a hydrogeologist with the British Geological Survey based in Wallingford, and today we're investigating the ground conditions on a site just adjacent to our offices with the Environment Agency. We have a team of 3 people looking at a car park and the geology just below the base measure of a car park. And we're now exploring what's happening with the soil and the subsurface just adjacent to that car park. We've drilled using a percussion drill to about 1 metre depth, and we believe we've hit bedrock slightly shallower than we expected. And if I take a look at the bottom of the core that we've extracted from the drill, I think we've come across some glauconitic marl, which we usually encounter below some Thames gravels, which are absent here. Earlier today we drilled a shallow borehole into the grass and also some boreholes into an adjacent car park, and what we're going to do now is to instrument up those boreholes with some soil moisture probes. I've got an example here which is a multi-level soil moisture probe, and it works on the basis of sending an electromagnetic field around 3 sensors in order to get a profile of soil moisture down this access tube. And we'll hook this device up to a data logger so that we can record the soil moisture at whatever interval we like, probably over a 10-minute interval, and have that telemetered to us in our adjacent office. We've also got these installed in the car park in order to compare the soil moisture in the grass with the soil moisture in the car park subbase. We're very interested in gaining data about the soil moisture content, so the amount of rainfall percolating through the grass at different levels, and also comparing what's happening in the soil with what's happening in the adjacent car park, so that when water drains through the car park, which is designed as a sustainable urban drainage system, we can see and compare the effectiveness of the drainage system in the car park. We're aiming to monitor the car park for the whole of the summer. We're just coming into spring now, so what will happen is that the soil moisture content will deplete, and during the summer the car park and the adjacent grass will dry out. Then as it re-wets during the autumn, we'll get a seasonal change. So we're getting some background information to how the soil moisture content and the car park moisture contents vary seasonally. The data is going to be used in order to monitor the effectiveness of different types of SuDS schemes, that's sustainable urban drainage schemes. In this particular case it's a car park and its surrounding areas, and behind me there's the development of another slightly different design car park. So we're really monitoring how the different designs are effective in distributing water, and how modifications can be made to the different car parks to make that more efficient.